Hello everyone. Today I will present work on modification of test protocol generation using knowledge graphs. This research is focused on industrial ground installations such as gas turbine engine GTEs, gas lift and oil transfer units, stationary gas turbine units GTUs, as well as next generation gas pumping station and power plants. Throughout the life cycle of GTUs, numerous tests are performed. During these tests, the operability of the plant as a whole and its individual components is verified. The tests are carried out in all operating modes specified by technical regulations. At the same time, critical operating parameters are continuously recorded as they reflect each specific mode. The accumulated data, often referred to as raw, must be processed and structured to prepare reporting documentation. This includes inspection reports, current test records, consolidated protocols for each stage, and summary data tables for operational documents such as passports and technical forms. A simplified GTU test process is shown in Figure 1 as a BPMN-based diagram illustrating the flow of reporting documentation. After the active testing phase, data processing and result analysis begin. Multiple current test protocols are processed to create a consolidated protocol where data is aggregated for the entire active phase. This consolidated protocol becomes the main source of a summary data table, which is used to fill technical forms and GTU documentation. The content and format of this documentation are defined by manufacturer requirements and standards, and follow a clear structure. In practice, this documentation is often prepared manually, which is time-consuming and error-prone. This large amount of manual work creates an opportunity for automation. This research focused on solving the challenges of automating GTU test data processing. Initial experiments in processing GTU test protocols using large language models with the RAG method showed low performance. The main challenges were handwritten Cyrillic text and the difficulty of extracting data from tables. Therefore, the focus was shifted to improving data retrieval from tabular data. This can be done by representing table structures as knowledge graphs and using structured template-based queries for the LLM. Analysis of protocol structures showed a clear hierarchy where information is organized from general to specific. This structure fits well with a hierarchical knowledge graph. Due to this hierarchy, protocol, parameter group, operating mode, value, the graph allows accurate retrieval of relevant data and improves traceability of the result. In addition, the knowledge graph improves prompt construction, turning them into dynamic and context-aware structures. The goal of this research is to improve data retrieval and logical inference from tabular test protocols by combining knowledge graphs, prompt templates, and LLMs. Based on the developed knowledge graph, the structure of the consolidated GTU test protocol and the summary data table are proposed and shown in the figures. A modified framework based on the knowledge graph has been developed. The structure of the consolidated test protocol is used to mark up the input protocol and identify structural elements in the semi-structured document. This includes defining classes, parameter groups, entities, operating parameters, relationships, and properties, operating modes and values. Next, knowledge extraction is performed. Entities and properties are identified directly, while specific entities are refined through tokenization. Then, knowledge fusion integrates these elements into a complete knowledge graph. Because the data is in tabular form, most entities and relationships can be extracted from the table structure. The resulting knowledge graph is used to generate the output document, the summary data table. The knowledge graph, including nodes, relationships, and hierarchy, is stored in JSON format. Embeddings for graph entities are created using the all-emset base with two-sentence transformer model and stored in FAISS vector database. When a query is made, it is embedded using the same model. FAISS then retrieves relevant information based on similarity search using L2 distance. The retrieved context is combined with the query in a prompt template, which guides the LLM to generate a structured response. Finally, the Llama server runs the model. The best results were achieved with the open source model Gemma 3 with 4.3 billion parameters using standard settings. Based on the structure of the summary data table, queries were constructed to generate the output data. Conclusions. Processing tabular data remains a significant challenge and requires specialized preprocessing. Integration of knowledge graphs and structured prompts improves search efficiency and data extraction. A modified framework based on knowledge graph has been developed. Prompt templates were designed based on input and output document structures. Experimental results show a 15% increase in search accuracy for large protocols. Future work will focus on full automation of report generation process. Thank you.